Okay, so this is the second part of your review. Okay, and there's 3 questions here. I'm going to do them in separate videos because I think they do, if I did all 3 in one, it would be too long. So I'm going to do question A, okay, first. And what this is asking us is to use the remainder theorem to figure out what the remainder is going to be for each of the divisions before we actually do the division, okay? And so what this is going to do, you remember the remainder theorem basically says the thing that we are going to divide into the polynomial, if I can like evaluate the function at, let's say 2 in this particular instance, then I can test to see what the remainder is going to actually be before I actually do the division. And so we use this idea of finding the remainder to then go into, well, what happens if the remainder turns out to be 0? And that's what we claim to be the factor theorem. So if we do this work that we're about to do and I get a 0 out, then that's what we're going to say that like x minus 2 would be a factor of this thing. And I could start following the what we call the factoring process of a cubic or a quartic relative to some of the quadratic stuff we've done in the past, right? You're trying to get to the polynomial written in factored form. And so with the remainder theorem was kind of an important theorem because it spun into what we used for the rest of the unit, right? And so what this is asking us to do is basically say, well, let's say right off the bat, let f of x represent the function that we are talking about here. So x cubed plus 9x squared minus 5x plus 3. And what remainder theorem is asking us is what's the remainder when I divide x minus 2 into that thing? And so what we can do is we can actually evaluate the function at 2, okay? And what you'll see is we can input 2 into x and then evaluate, and we should get the remainder come out. And so part 2 of this question, so this is part 1 at the moment, part 2 will actually do the division and see if the 2 remainders match, okay? So we can actually do the math here. So f at 2 is going to be 8 plus 9 times 4 minus 10 plus 3, and so that should be 8 plus 1836 minus 10 plus 3, and so f at 2 should come out to be 37. Okay, so that's your remainder in theory. And now what we're going to do is use some form of division to figure out whether or not that holds true. Okay, and so this question is nice because I can actually show you all of the different kinds of it's either synthetic division or long division. I'm going to do synthetic for this first one for the reason that like we talked about in class. You could use synthetic for all 3 of these questions and we'd be fine. There's just one precautionary measure we have to take in, with things that when we have what we say rational roots. Okay, so we just got to be a little careful. But for right now, I think I'll do like maybe a mixture of the division, like either synthetic or long, just so that we get a couple videos done. So I'm going to do the first one as synthetic, and what synthetic said was I can take the thing we are dividing in this case 2, or the thing that we're looking for the remainder of, and we're going to synthetically divide it in, so using the coefficients that exist in front of each of the terms, okay, within the polynomial. So 1, 9, negative 5, and positive 3. We'll just leave it as 3. Okay, and when I divide things in, like if I were to remove that x minus 2 factor, then the degree of the polynomial is going to decrease by 1 because I've pulled one of the factors out. And so the way we do that is we're going to drop the 1 down, okay? And then these down here are going to represent the new coefficients of the quadratic relative to the cubic that we're started with, okay? So we're just going to go through the process of synthetic division. So I'm basically taking the side number and multiplying it by the bottom, and then putting it here. So this is going to be 2. And then I add to find the next number. So this is going to be 11. and then you repeat the process until you're done. So 2 times 11 is going to be 22. If I add those two things together, I get positive 17. 2 times 17 is going to be 34. If I add them together, I get 37. Okay, so this would be, because it's asked here, we can identify any restrictions too. So perform the division and express the results in quotient form. So here's what we've got. We have x minus 2 multiplied against x squared plus 11x plus 17 plus the 37 remainder over what it was I divided by in the first place, which would have been, we're going to say x minus 2. Okay, this was the thing that I originally divided by. That's what it asked us to divide by in the beginning. Okay, so if I were to expand this out, and we discussed this in class, maybe I'll bring it down here so you can see this whole thing. If I were to expand it out, I would get back x cubed plus 9x squared minus 5x and then plus 3. Okay, so if I actually did the multiplication of all the terms, right, I would get this side back out again. Okay, and so we have one more little piece here, and it would be x could not be equal to 2, because then I would get a 0 underneath there. Okay, so that's pretty much everything that number 1 is asking of us. There's 2 more questions to do. They have some rational roots, or what they're not necessarily roots, but they have rational quotients. Okay, I can do one with synthetic and one with long division, and that's it. Okay, so just watch for the next couple videos.